Look up. On a clear night far from the glare of city lights, the universe reveals itself. You see a velvet black canvas, splattered with the diamond dust of countless stars. Each point of light is a sun, many of them likely circled by their own worlds. This view stirs something deep within us, a feeling of wonder mixed with a profound sense of humility. We are small, but we are part of this vast, interconnected cosmos. It all began on a hot summer day in Florida, August 20th, 1977. A powerful Titan IIIe rocket roared to life, piercing the blue sky and carrying a precious cargo, the Voyager 2 spacecraft. It was a moment of immense hope and calculated risk. This was not just another satellite destined for Earth's orbit. This was a messenger, a scout, launched on a trajectory that would take it farther from home than any human-made object had ever intended to go before. Its mission was to explore the outer giants of our solar system: Jupiter, Saturn, Uranus, and Neptune. And then, if it survived, to keep going, venturing into the uncharted territory between the stars. What made Voyager 2's mission so special was an extraordinary celestial alignment, a rare geometric arrangement of the outer planets that happens only once every 176 years. By flying close to a planet, the spacecraft could borrow some of the planet's orbital energy, like a slingshot, to fling itself onward to the next target at a much higher speed. For decades after its final planetary flyby, Voyager 2 sailed through a region of space that is still part of our solar system, but is profoundly different from the space between the planets. The sun constantly blows out a stream of charged particles called the solar wind. This wind travels at supersonic speeds, creating a vast magnetic bubble around our solar system called the heliosphere. Then, on November 5, 2018, something remarkable happened. Voyager 2's instruments registered a sudden and dramatic drop in the number of solar wind particles. At the same time, there was a massive surge in the intensity of high-energy galactic cosmic rays, particles forged in distant supernova and other violent stellar events. When we talk about the edge of the solar system, it's easy to picture a solid wall. To understand this, imagine you're standing by a large bonfire on a windy night. The heliopause is the point where the pressure of our sun's solar wind is no longer strong enough to push back the wind from other stars. It's not a solid wall, but a turbulent, dynamic boundary where two powerful cosmic winds collide. Voyager 2's crossing of this boundary was so important because it gave us our first direct sample of this interaction. While Voyager 1 had crossed the heliopause in 2012, one of its key instruments for measuring plasma had failed years earlier. Voyager 2's plasma science instrument was still working perfectly. This meant it could measure the density, temperature, and speed of the plasma on both sides of the boundary. It confirmed that the heliosphere acts as a cosmic shield, protecting our solar system from the harsh radiation of interstellar space. The discoveries made by Voyager 2 as it crossed into interstellar space are not just interesting trivia, they are fundamentally reshaping our understanding of how solar systems interact with their galactic environment. For the first time, we have ground truth. We are no longer guessing what the space between stars is like based on light that has traveled for eons. One of the most mind-blowing implications of Voyager 2's data concerns the shape of our heliosphere. Furthermore, the information about galactic cosmic rays is vital for the future of human space exploration. These high-energy particles are a major hazard for astronauts on long-duration missions to Mars or beyond. This data is essential for designing the shielding and life support systems that will be needed to protect astronauts once they venture beyond the protective cocoon of our sun's influence. The story of Voyager 2 is far from over. Attached to the side of the spacecraft is a golden record, a 12-inch gold-plated copper disc. The record contains 115 images of life on Earth, a variety of natural sounds like wind and thunder, spoken greetings in 55 different languages, and a selection of music from different cultures and eras, from Bach and Beethoven to Chuck Berry. It is a portrait of our world, a greeting card to the cosmos that says, "This is who we were. This is what our world was like." It is an act of profound optimism and a bridge across the eons. This mission inspires us because it embodies the best of what it means to be human, our boundless curiosity, our technical ingenuity, and our hope for connection. The journey of this one small probe elevates our perspective, urging us to see ourselves as citizens of the cosmos. So the next time you feel small or wonder what our purpose is, remember Voyager 2. Remember this tiny, tenacious explorer, now more than 12 billion miles from home, faithfully sailing through the star-dusted darkness. It is a symbol of our own potential, a reminder that even a small, fragile species on a single, ordinary planet can reach for the stars and touch the void. Its journey is a continuous source of inspiration, a call to the next generation of dreamers, scientists, and explorers to push the boundaries even further, to keep asking questions, and to never, ever stop exploring the magnificent universe we are so lucky to be a part of.